Hello, math friends. Let's do some review of ratios and proportions. So we're going to flip this lesson and we're going to flip the next because we didn't really get too far into it in class today, which is fine. You're just going to have to watch it, and if you're confused or stuck, remember you can always hit pause and rewind and do whatever. But most of all of this is review besides the undefined. So you should be good. And I'm going to only do part of the notes, and I want you to fill in the rest. So I'll give you an example, and then you're going to try one, so on and so forth. Okay. So let's start with the actual flip lesson, which is on ratios and proportions. And we're going to start with the ratios. Define, which is a ratio is a comparison. It is a comparison of two quantities. All right, two numbers. So how can you write or express a ratio? We can write it as a fraction, one of our favorite ways to write it. We can write it with a colon. And we can also write it with words of two. Okay, but the most common form for us is a fraction. That is the most common way we write it. Okay, a proportion is when two ratios are equal. Okay, that is a proportion. All right, so since a ratio can be written as a fraction, it can also be written in any form that is equivalent to that fraction. So these are fractions. Let me say that again. Since a ratio can be written as a fraction, it can also be written in any form that is equivalent to that fraction. So examples of 3/15. So another way to write this would be reduced, which would be 1/5, or 1/5, or 1:5, or 0.2. If I wanted to write it as a decimal, I could take 1/5 and divide it, 1 divided by 5, and get 0.2, or as a percentage. I could take that decimal and convert it to a percentage. Now, notice, I did this really quick. When you take 3/15, we typically want ratios in the reduced form. So that's how I reduced it to 1/5. And then I wrote all of them in a 1:5 ratio from there. Okay, now, if I use the 2, remember the 1 has to go first because that's the numerator. Just like in the colon, the 1 goes first with the colon. Okay, whatever's the numerator, that's what you're going to write first in the 1/5 or the 1:5. Numerator always goes first. Order is important with these. Has to go in the right order, which takes me to this problem. A soccer team played 25 games and won 17. So, if they won 17, that means they lost 8, right? Because they played 25 games. 25 minus 17 is 8. What is the ratio of the number of wins to the number of losses? So order is important. You start with wins, right? And you write it to losses because that's how they want it. Based on what they say in the problem is how I want to write it. Wins to losses, easy. 17 wins to 8 losses, okay? Again, can be written as any of those up on the top, but we're not going to go into all of them. You understand, instead of a 1/5, it's a 17 to 18, okay? You're going to do 1B, and then we're going to check it tomorrow, okay? So you do 1B. Let me keep moving, though, so we can get through this. Okay, the second example is the Yankees won 125 games, the Mets won 95 games, and the Red Sox won 80. All right, so I want to do this one. I want to do it as a fraction because I told you we use this fraction form the most. So what is the ratio of Mets to Red Sox wins. Mets to Red Sox wins. Okay, Mets go first. Goes on the numerator. 95. Red Sox wins is 80. Goes on the denominator. I'm going to reduce that. That means it's a 19 to 16 ratio. That means this. For every 19 Met wins, we will have 16 Red Sox wins. That's what that means. Let me say that again. For every 19 wins for the Mets, we will have 16 wins for the Red Sox. Okay? Again, you're going to do 2B, and we'll check it tomorrow. We're going to keep moving. Okay. 3. Solving ratios and proportion word problems. Okay, so really what you're going to do is you're going to use these ratios in the colon format, and we're going to actually create a word problem from it. Okay, so if I say two numbers are in the ratio of 5 to 3, and their sum is 80, find the largest number. This means that one number is 5 parts to this number's 3 parts. Okay? So we don't know how many total. Like, for example, up in the top there in the hint, it says when working with ratios such as 2 to 3 to 5, we're going to use 2 to some part, to 3 to some part, to 5 to some part. And we're going to write an equation from that. So when I see a 5 to 3 ratio, I'm going to say let the 5x, and I do like let statements for these, by the way, let the 5x be the larger number, and the 3x be the smaller number. And since it tells me that the sum is 80, there's my equation. 5x to 3x is going to be a total of 80. And I'm going to solve. Pretty straightforward. 8x is equal to 80. Divide by 8, divide by 8. X is equal to 10. Now that does not mean that's what the number is, because it says find the largest number. It just means that I have 10 to the 5. Okay, I'm going to put it up here, come up here, and I'm going to say x is now equal to 10. So 5 times 10, 5 times 10 would be 50 for the larger number. And then, just so you know for the record, 5 times 10 would be the smaller number. So I, again, look at that x as parts. I got 5 parts to the larger number, 3 parts to the smaller. When I figure out what that part is, or that x value, then I plug it in, and it's 50, and I want the larger number, so that's my answer. It's always good to check, though. To 30, which is the smaller, when I add 50 and 30, I get 80. Works perfect. So this is what I'm going to do. I'm going to leave you 4 and 5 to try on your own. Okay? 4 and 5, you're going to try on your own. Okay? We're going to get to that next lesson. All right? And I do want you to also do the warm-up. So you're going to do the ones that we left in the last page, last 2 pages. You're going to try this warm-up because it's a warm-up from that piece that we just did. You try them, okay? And we're going to get to the proportions piece right now, okay? All right. So a fraction is undefined when the expression in the denominator is equal to 0. And I had said this in class really quick, but I'm going to redo it so that you have it in your notes and it's right, because I know some of you were packing up. This is also called a restricted domain. And I know that you are familiar with domain. Domain are the x values. Remember, in range are the y's. And it'll come into play a little bit more later on when we do some other stuff in upcoming units. But just know that when we talk about undefined, we're restricting the domain, or we're restricting basically what the x value can be. Because you can't divide by 0, okay? So if I look at number 1 and I say determine when the following rational expressions are undefined, I want to know what x value will make it undefined. If I come here, okay, and I say what would the x be in order for me to have a 0 on the bottom, you're just going to say, well, x will have to be 0 then, right? Because 3 divided by 0 is undefined. And that's your answer. That's it. Again, remember the question says determine when the following rational expressions are undefined. So we're saying that 3 divided by x will be undefined when x is 0. You don't want to say necessarily, we're not going to use x equals 0. We're just going to say the value is 0. Okay? Now, look at the second one. The denominator is x minus 5 in this case. Okay? I think we want to find out when the denominator will be 0. Okay? So, set it equal to 0 and solve. And we know it will be undefined when x is equal to 5. Okay? When x is equal to 5, it will be undefined. Ooh, I like number 3. Love it. What's number 3? Well, I told you guys the other day when we have an x squared, and actually I'm not even going to set it equal to 0 because you don't know how to solve that yet. You will with equations, but not yet. I want you to use your noggins right now. What x values, there's 2, will make that undefined? And I will give you a hint. One of them is 5, because you know 5 squared is 25, right? So if I were to put 5 in there and square it, I would end up with a 0 there, right? 5 squared is 25. 25 minus 25 is 0. So that's one of the answers. What is the other? I'm hoping that a bunch of you did this. A positive and a negative. Can't be a negative either. Think. Use those noggins again. If I were to square a negative 5, I get 25. And 25 minus 25 again is 0. So you have 2 solutions. Okay. You're going to try 5 and 6 on your own. I should see that tomorrow when we come in. I'm going to have you pull your notes out. This should all be completed. Look at 6. 6 is going to have 2 separate solutions. You got 2 x values here. So x could be, if x was 0 here, it would make this whole thing, the whole denominator, equal 0. Or what's this x going to value have to be in order for the inside to be 0? So basically x plus 7, what would I need to put in for x for the inside of the parentheses to be 0? Hopefully you figured that out. That would be negative 7. Now how is it that there's 2 answers? Well, let's check them. So here's my denominator. Okay, here's my denominator. If x was 0, then, okay, 0 times 7 is 0. We can't have 0 on the denominator. So x can't be 0. If x were negative 7, look at this. Negative 7, inside the parentheses, negative 7 plus 7 is 0. Oh, there it is again. Negative 7 times 0 is 0. So if I have 2 separate x values in the equation, or in the denominator, I have 2 possible answers. Okay? So my answers for this one are going to be 0 and negative 7. Alright? Okay, now, this is review. This is the part that should be review for you. Okay? Now, it's to solve the equation for x, excluding or restricting the x values the values of x that lead to a denominator of 0. Okay? So in this case, first thing I'm going to do is I'm going to look at those denominators. And I'm going to say, all right, I've got a denominator here where x can never be 0. And then I have a denominator here where x can never be positive 2. Because if it were 2, 2 minus 2 is 0. So when I ask for, I'm excluding the values of x, right? I'm going to write it this way. X will never be 0 or 2. Right? I always list those first. Then what I'm going to do is I'm going to solve for the proportion. Now, you learned how to do this in the past. So what you're going to do, remember, is you're going to cross multiply. So you're going to do 1 times x minus 2. 1 times x minus 2. We're going to set that equal to x times 3, which is the other cross part. And no more fraction. It's gone. That's the beauty of cross multiplication. Okay, so you're going to rewrite it. You're going to solve for x. I get negative 2 is equal to 2x, and then you're going to divide by 2. Running out of room. Uh-oh. I just jumped. Hold on. I hit the wrong button, apparently. Let me see if I can get this. There we go. And negative 2 divided by 2 is negative 1. So your solution, and if we were to write it in set notation, ax, such that x is equal to negative 1, but x cannot equal 0 or 2. And we would do little squigglies around all that. Okay? Jammed it in. Let me do another one. Kind of jam that answer in. Okay, I'm going to look at this. I'm going to do the cross multiply. Let's list first what x cannot be. X cannot equal 0. And x cannot equal 4. Okay, those are the restrictions. I'm going to cross multiply, so I'm going to do 2, using my distributive property again. 2 times x minus 4. Make sure you use that distributive property. And x times 3. And then I'm going to distribute the 2. So it's 2x minus 8 is equal to 3x. I'm going to subtract the 2x. And I've got negative 8 is equal to x. And I've got, let me write this again, much cleaner this time. I'm going to do it in set notation. X such that x is equal to negative 8, but x can never be, because we've got to tell what the restrictions are, 0 or 4. And there it is. Much neater than number 7. Okay? What do you think so far? Remember all this good stuff? All right, I'm going to have you try 9 and 10. I am going to do this. I'm going to hold off on 11, and I'm going to I'm actually going to just let you try 11. I'll let you guys try 11, and then we're going to talk real quick about 12. All right, I'm going to have you look at 12 real quick. So it says write an equation with the restrictions x equals 5 and x cannot equal 5 and x cannot equal 2. So I basically want you to write a proportion where these would be the denominator. So if I got x can't equal 5, then my denominator here would be x minus 5. Oops. And if I have one where x cannot equal 2, I'm going to have x minus 2 would be there. And then we're going to come up with like maybe 6 here and 4 here. And you got some kind of proportion. All right? And I'm going to let you look at 13. All right, so these are the ones you're going to do when you turn this video off. And then we're going to kind of go through 14, part of it, and then I'm going to let you finish this one too. Okay. This one's tricky, so you got to stay with me. Okay. Ross wants to cut a 40-foot rope into 2 pieces so that the length of the first piece divided by the length of the second piece is 2. So let x out. So basically you're taking a 40-foot rope and you're going to cut it into 2 parts. So let x represent the length of the first piece. Okay, x is the first piece. Right? Write an expression to represent the second. Okay. So let me say this to you. If I got a 40-foot rope and my first piece is 10 feet, then what's my second part? What's my second piece? Wouldn't it be 30? Right? So if my first one was 10, my second one would be 30, because really all you would do would be 40 minus 10. True? So think of it that way. We don't know what our first piece is. We don't know that it's 10. We're calling it x. So to get my second piece, I'm literally going to say whatever 40 is, I'm going to minus that first piece, and the leftover is going to be my second piece length. Okay, so we're talking about the lengths of the second piece. Whatever the first piece is, calling it x. To get the second piece, it would be 40 minus x. All right, now it says write an equation that represents the relationship between the 2 pieces stated above. Now remember what it said. They cut it into 2 pieces so that the length of the first piece is divided by the length of the second piece. Okay. The length of the first piece divided by the length of the second piece is 2. Is equal to 2. All right. Now, I know that seems kind of tricky, but at least we set you up with it. Now, what I want you to do for the rest is to take that equation from B, and then you're going to answer C, and then you're going to solve for it in D. Okay? All right, kids. Thank you for listening. Hopefully, we are in good shape with proportions when you come in tomorrow. If you have any questions, I want you to go through and finish the rest of the notes. If you have any questions, then let me know, and we can do them tomorrow in class, but make sure you at least attempt the ones that we did not do in the note packet, and then we'll go over them. I'll put them up on the board tomorrow, okay? Have a good night.